Hello everyone, welcome to the next video of semiconductor diodes tutorial. In this video, PN junction diode is explained in detail. At the end of this video, important questions on PN junction diode are given. In this video, we will discuss how PN junction is formed, then the formation of depletion region, concept of barrier potential of PN junction diode symbol and its working, and last point will be VI characteristics of PN junction diode. So let's start with the video. First we will discuss formation of PN junction and depletion region. PN junctions are formed by joining N-type and P-type of semiconductor materials as shown in the figure. As we know that N-type region has electrons as majority charge carriers and P-type region has holes as majority charge carriers. When PN junction is being formed, holes diffuse from the P side to the N side, while electrons are diffused from N side to P side. This happens due to the concentration gradient across P and N sides, and this gives rise to diffusion current across the junction. Now let's look at two conditions. Case number 1, electrons diffuse from N side to P side. This diffusion leaves an ionized donor, that is positive charge, on the N side. This donor is bonded to the surrounding atoms and it is immobile. As more and more electrons start diffusing to the P side, a layer of positive charge will be formed in the N side of the junction, and the junction is formed. Suppose case number 2, holes diffuses from P side to the N side. This diffusion will leave the ionized acceptor, that is negative charge, on the P side. As more and more holes starting diffusing to the N side, a layer of negative charge on the P side of the junction is formed. Since the diffusion of electrons and holes across the junction depletes the region of its free charges, these space charge regions together are called as depletion region. Now let's talk about barrier potential of PN junction diode. The electric field formed in the depletion region acts as a barrier. External energy must be applied to get the electrons to move across the barrier of the electric field. The potential difference required to move the electrons through the electric field is called as barrier potential. Barrier potential of PN junction depends on the type of semiconductor material used. Amount of doping and temperature also affects barrier potential. The approximate value of barrier potential for silicon is 0.7 volt and for germanium it is 0.3 volt. Now let's discuss the symbol of PN junction diode. A PN junction is an interface between two semiconductor material types, namely P-type and N-type. It has single PN junction. The positive terminal is anode and negative terminal is cathode. Now let's focus on the working of PN junction diode. The external voltage applied to the PN junction is called as bias voltage. Depending on the polarity of external source to the PN junction, we have two types of biasing. They are forward bias and reverse bias. If the positive terminal of the external voltage source is connected to the P side and negative terminal is connected to the N side, it is called as forward biased, as shown in this figure. The application of forward bias potential makes the electrons move into the N side and holes into the P side. This initiates recombination with the ions near the junction, which in turn reduces the width of depletion region, and because of that barrier potential also gets reduced. The electron from N side is now accelerated towards P side as it experiences a reduced barrier potential at the junction. In addition, the accelerated electrons experience a strong attraction by the positive potential applied to the P side. This results in the movement of electrons towards P side and in turn holes towards the N side. When the applied voltage is increased, the width of the depletion region and hence the barrier potential are further reduced. This results in a large number of electrons passing through the junction, resulting in an exponential rise in current through the junction. If the positive terminal of battery is connected to the N side and negative is connected to the P side, then the junction is said to be reverse biased, as shown in the figure. As the positive potential is connected to the N-type material, the electrons in the N-type material are attracted towards positive terminal. In turn, the holes in the P-type material move towards negative terminal. It increases the immobile ions at the junction. The net effect is the widening of the depletion region. It also leads to the increase in barrier potential. The majority charge carriers from the both sides experience a great barrier to cross the junction. This reduces diffusion current across the junction effectively. Yet, a small current flows across the junction due to minority charge carriers in both regions. The reverse bias for majority charge carriers serve as a forward bias for minority charge carriers. And the current that flows under reverse bias is called as reverse saturation current. It is represented as IS. The reverse saturation current is independent of the applied voltage and depends on the thermally generated minority charge carriers. Even a small voltage is sufficient enough to drive the minority charge carriers across the junction. So, as a summary, we can say that when the diode is connected in forward bias condition, as shown in this figure, then it will reduce the width of the depletion region and hence the barrier potential. When the diode is connected in a reverse bias state, then width of the depletion region increases and therefore barrier potential also increases. Now, let's talk about VI characteristics of PN junction diode. VI characteristics of PN junction diode is a curve between voltage and current through the circuit. Voltage is taken along x-axis while current is taken along y-axis. This graph is the VI characteristics curve of PN junction diode. With the help of the curve, we can understand that there are three regions in which diode works: zero bias, forward bias, and reverse bias. When the PN junction diode is in zero bias condition, there is no external voltage applied, and this means that potential barrier at the junction does not allow the flow of current. When the PN junction diode is in forward bias condition, that means P type is connected to positive terminal, N is connected to negative terminal of the external voltage. And when the diode is arranged in this manner, there is a reduction of potential barrier. For silicon, it is 0.7 volt. For germanium, it is 0.3 volt. The potential barrier decrease and there is a flow of current. When the diode is in forward bias, the current increases slowly and the curve obtained is non-linear as the voltage applied to the diode overcomes the potential barrier. Once the diode overcomes the potential barrier, the diode behaves normally and the curve rises sharply as external voltage increases. The curve obtained is linear. When the PN junction diode is in negative bias condition, means P type is connected to terminal and N type is connected to positive terminal of external voltage. This results in an increase in potential barrier. Reverse saturation current will flow in the beginning as minority charge carriers are present in the junction. When the applied voltage is increased, the minority charges will have increased kinetic energy, which affects the majority charges. This is the stage when the diode breaks down. This may also destroy the diode. So this is about VI characteristics of PN junction diode. Now let's move to the last point, that is applications of PN junction diode. Photodiode is one of the special type of PN junction diode which uses light energy to produce the electric current, which is the important application of PN junction diode, where we need to connect the PN junction diode in reverse bias condition. The second application is clipping circuit. The clipping circuit is used to help the limiting voltage levels so that they don't exceed the threshold voltage level. These diodes help clip the signals due to their unidirectional nature so that signals don't cross the threshold voltage limits. Diodes can be used in clamping circuits as well, which is the next application of diode. Clamping circuits control the levels of voltage so that waveforms don't exceed certain threshold values. The diode can be used to clamp by redirecting the waveform and preventing it from exceeding certain specific level of voltage. Logic gate is the next application. PN junction diode can be used in making logical gates or circuits and implementing the basic logical functions like AND, OR, NOT, etc. These are used in digital circuits. PN junction diode can be used in LED lighting applications. The diode should be connected in forward bias state when it is used as a LED. The last application is it is used as a rectifier in many electric circuits and as a voltage control oscillator in varactors. So these are the applications of PN junction diode. Now, next slide is about important questions. These are the important questions of PN junction diode topic, and the answers of all these questions you may get in the same video. So this is about PN junction diode. Thank you for watching my video.